Hi, welcome back to the channel. In this lesson, we'll see discriminants of a quadratic equation. I'll start by explaining the discriminant of quadratic equations and their effects and how to use them in quadratic expressions. After which we'll see a typical example to help us understand it better. That said, let's get into it. Hi, welcome back. Quadratic expressions are generally of the form of ax squared plus bx plus c is equals to 0, or I say is equals to y. Now, this is the general expression for a quadratic equation. Now, there are different ways to solve this quadratic equation. One of those ways we solve quadratic equation is by the formula. The formula says that my x will be given as minus b plus or minus square root of b squared minus 4ac over 2a. I've done a video where I explained how to derive the formula. I'll place a link to that video in the description below. Now, but one unique thing you must observe in this formula is that this part of the formula that says b squared minus 4ac is referred to as a discriminant. It helps us determine the state of that quadratic equation, if that quadratic equation will have a real root, if it has distinct, if the quadratic equation has distinct roots, if it has just one root, and if it has no real roots. Now, how do we achieve that? Remember that if I have the square root of 4, the square root of 4 is the same thing as plus or minus 2. That is, if I have plus 2 raised to power 2, it will be the same thing as 4. If I have minus 2 raised to power 2, it will be the same thing as 4. The same thing happens in here. I can interpret this to be the same thing as x now is equals to minus b plus or minus square root of d, where d is my discriminant, and d now is the same thing as b squared minus 4ac. When the value of d is greater than 0, we say that this equation has distinct roots. It has distinct roots. That is, the value of d is positive. But when the value of d is equals to 0, we see that this equation has a single root. It has no repeated roots. And when the value of d is less than 0, that is, the value of d is negative, we say that the value of d, we say that the equation has no real roots. Has no real roots. Now, this is a simple analogy. When the value of d is greater than 0, value of d is positive, that is my minus b plus or minus the square root of d, that's positive, over 2a will lead to a positive value in here. So I must definitely get distinct roots. But when this value is equals to 0, when it is equals to 0, the expression becomes minus b over 2a, which is just a single expression, or rather a single value. But when the value of d becomes negative, that is my minus b plus or minus the square root of minus d, the value of d is negative in this instance, then I cannot solve this. It becomes a complex number, so it has no real root. Now let's take an example. My example says I should find the value of k for which this is x squared, for which x squared plus ax plus 9 has equal roots. That is, it has two roots, equal roots, two roots that are equal in value. Now, this happens when d is equals to 0. Now, for d to be, let's now, now my question says x squared plus ax plus 9. Now, for us to solve this, we'll liken this equation to the form of ax squared plus bx plus c, where my a obviously will be equals to 1 because the coefficient of x squared here is 1. My b here will be equals to k, and obviously my c will be equals to 9. Now to determine the value of k when it will have equal my d must be equals to 0. So that my d now, which is equals to b squared minus 4ac, must be equals to 0. Now my b here is k, that's k squared minus 4 into a here is 1, and my c is 9 is equals to 0. So that at that stage, k squared minus 36, 9 times 4 is 36, is equals to 0. K squared is equals to 36. Obviously, I'll find the square root of both sides, and k will be equals to plus or minus 6. So at that value, for this to have equal roots, my value of k must be the same thing as plus or minus 6. Now let's inject the value of k into this equation and now see the roots. This is x squared plus 6. When it is plus 6 plus 9 is equals to 0. X now, let's factorize. X multiplied by 9 will be the same thing as 9x squared. What are the values of 9? What are the factors of 9x squared that when I multiply them together will give me 9x squared, and when I add them together will give me 6x. Sorry, this 6x. Now that will be 3x. That's x squared plus 3x plus 3x plus 9 is equals to 0. So that x now into x plus 3 plus 3 again into x plus 3 is equals to 0. Now if you see it, you now know that we have equal roots that are repeated. X plus 3 is equals to 0 and x plus 3 is equals to 0. This implies that x obviously is equals to minus 3, x is equals to minus 3. So in the two instances, x is equals to minus 3, obviously the value of k is equals to plus 6 satisfies this equation to give us two equal roots. Now you can try that on your own and try for x minus 6. So that when k is equals to minus 6, I'll have x squared minus 6x plus 9 is equals to 0. Now try it so that the factors, let's multiply this by 9 like we did initially, that's 9x squared. What are the factors of 9x squared that when you sum them up together will give you minus 6, that's minus 3 minus 3. Now this will become x squared minus 3x minus 3x plus 9 is equals to 0. X comes out, I have x minus 3. Minus 3 comes out again, I have x minus 3 is equals to 0. So that you can see the two factors, x minus 3 now is equals to 0, x minus 3 again is equals to 0. From here, x obviously will be the same thing as plus 3, and also from here, x obviously will be the same thing as plus 3. So in both instances, when k is equals to either plus 6 or minus 6, it has two equal roots. Thank you for this. I hope you understand how to work with discriminant. In our next lesson, we'll take another question to help us understand it better. Thank you for staying with us and see you in our next class.